This is an assignment problem where we use row reduction and column reduction. It is an unbalanced problem, so we will try to balance it. It has 5 columns and 4 rows. Balanced problem will have number of rows is equals to number of columns. Now in this we have tried to balance the problem by adding a dummy row. The dummy row will be all 0 values. Now the next step will be row reduction. To perform row reduction, we have to find the minimum value from each row. For example, in the first row, the minimum value is 2. The second row, the minimum value is 7. The third row, the minimum value is 5. The fourth row, the minimum value is 7. And the last row, fifth row, the minimum value is 0. Now after finding each row minimum, we have to subtract this row minimum value with each entry of the row. So the new table will be, now 10 minus 2 will be 8. 11 minus 2 will be 9. 4 minus 2 will be 2. 2 minus 2 will be 0. 8 minus 2 will be 6. In similar fashion, we'll subtract each row entry with the minimum row value. Similar way, we'll get this table. This is the result of row reduction. Now from this result of row reduction, now we have to perform the next step will be column reduction. In similar fashion, each column find the minimum value from each column. Now we have find the column minimum of each from among the each entry present in each column. Since each column has minimum of 0, so we have written all the column minimums. Since 0 will not make any difference even if we subtract, so the table remains the same. Now we'll perform row scanning. Now in row scanning, each row will scan and try to find zeros present in each row. If we find 1 0 in each row, only if and only if 1 0 is present, we'll mark the 0 and whichever position the 0 is present, we'll delete that column. Similar way, first row is finished, second row again. Now in the second row we have 1 0, so it is eligible to be marked. And since the 0 is marked, we can strike the column. Again in the second row there is no 0. Third row there is 1 0. Fourth row. So we'll strike it. And in the last row we have 0. But the 0 is multiple 0, more than 1. So it is not eligible to be marked. This is what is row scanning. Now perform column scanning. What is column scanning is, in each column. Now this one is deleted one. We'll not look into this. Now each column, if there present any 0 within the table, and that there should be only 1 0. If in the column there present 1 0, mark that 0 and strike that row in which the 0 is present. So when you're doing row scanning, you mark the cell and strike the column. When you're doing column scanning, you mark the cell and strike the row. Now in the next, we don't have any 0. The 0 was there, already got deleted. So we don't have 0 in this column. This and this is already deleted. So now we have to count the marked cells. What is marked cells? This is marked 0 or squared 0. So how many are there? 1, 2, 3 and 4. So number of marked cells, should be equal to number of rows. We have 1, 2, 3, 4 and 5 rows, and we have 1, 2, 3 and 4 marked cells, which is not equal. Now the next step, find the minimum value from the table among the cells which is not deleted. So we'll look at the table among the undeleted value. Now among the undeleted value means 9, 4, 1, 8, 2, 3, 4, 4. These are the undeleted value and rest is the deleted value. From these undeleted value, find the minimum value. The minimum value is 1. Okay. So the minimum undeleted value is 1. Now add the minimum value, that is 1, to all the intersected value. Add that minimum value 1 to all the intersected value. What is intersected value? When your strike, vertical and horizontal strike meets, that is called intersection. So these intersection values should get added with 1, with the minimum value. So 0 plus 1 is 1, 0 plus 1 is 1 and 0 plus 1 is 1. So we have got 3 intersected value in our table. Next step. And subtract the minimum value with all the undeleted values. Now, we have seen the undeleted values. You have to subtract the minimum value with all the undeleted value. Now, 9 minus 1 is 8. 4 minus 1 is 3. 1 minus 1 is 0. 8 minus 1 is 7. Similar way, this column also. So we have to do all these things between the undeleted values. So the new table will be, this is what my resultant table is after doing with the minimum value, adding into the intersected value and subtracting with the undeleted values. I hope you remember what I told. So these are my intersection value 1, 2 and 3. So here it has added 1, 2 and 3. And 9 minus 1 is 8. 4 minus 1 is 3. So these are my table. You remember this column was already deleted. These 3 columns were already deleted, so I'll delete it. Now again we'll perform row scanning and column scanning. In this row, no 0, no 0, 1 0 I have. So I'll mark this and I strike it out. Okay. So I have earlier this as my marked cell, this as my marked cell, and this as my marked cell. Okay. Now just if you want, you can check. Since there is no availability of 0, I cannot do column scanning, but still this is already deleted, this already deleted, there is no 0 here, this is already cut if you see properly. So there is no among the undeleted value there is no 0, this is already deleted and this is already deleted. So there is no scope of doing column scanning. Now again find the marked cell, count the marked cells. Sorry, count, this was earlier marked cell, so I have just written it again. So 1, 2, 3, 4 and 5. I told you earlier the number of marked cells should be equal to the number of rows. So here number of marked cells or zeros should be equal to number of rows, which is 5 equals to 5. If this is achieved, we have reached the optimality. Now, how to find the answer after this? Since we have reached the optimality, what is my optimal answer is? Now, these are jobs. The rows are jobs. Okay? See, here it is machines, here it is jobs. And the table value is the time required to perform that job on that particular machine. So first we'll write all the rows, that is row number 1, 2, 3 and 4 and 5. Okay, so we have 5 rows. Now what about the operators? Okay, so operators will be the only which is marked cell. Tell me in which column and which row the marked cell is there. So for the first row, the marked cell is at position number 4. First column, second column, third column and fourth column. So the marked cell at first row is at fourth column. So I'll write 4. In the second row, the marked cell is at first column. In the third row, the marked cell is at second column. In the fourth row, the marked cell is at fifth column. And the last row, the marked cell is at third column. Okay, have you understood till now? Now go back to the table and find the cost or the time, find the time at first row, fourth column. First row, fourth column in the original table. First row and fourth column. First row and fourth column. The time required is 2. So I'll just write 2. Next, second row, first column. Second row, first column, 7. So I'll write 7. Then third row, second column. Third row and second column is 6. Fourth row and fifth column. Fourth row and fifth column is 7. fifth row and third column. Fifth row and third column. It is 0. Okay. Now you do the summation of all this. That is 2 plus 7 plus 6 plus 7 plus 0, which is equals to 22 hours. Required to do the job is 22 hours. I hope you have understood the problem. Thank you.